This test plan will briefly discuss the test plan proposed for the CDR and how it has been modified for the advances made leading to the FDR. The PDU has 6 sets of outlets, with one permanently tied to each phase and the other with the ability to switch the respective load to a different phase. As you can see on the PDU, the outlets marked by a strip of electrical tape above them have the ability to switch. The test presented in the CDR was designed so that the balanced solution would place a roughly 180 watt load across each phase, but starting with an initially unbalanced situation, with the loads on each phase ranging from roughly 90 watts to 270 watts. For simplicity's sake, only one load was placed on a switchable outlet, but the proper switching of this load would be capable of producing a balanced solution. Before testing, each of the loads were correctly hooked up to the respective outlets based on the test plan, and power is safely provided to the power distribution unit by the Hamden machine. And the National Instruments data acquisition card, located inside the PDU, was connected via USB to the main computer. With updates to the LabVIEW code, this initial test was modified with 2 new areas of interest: black start functionality and selecting the most balanced load. The first test in our new plan is to ensure that the updates to the code allow for black start capabilities. In a somewhat unconventional manner, the code does allow for black start capabilities by delaying the initial closing of breakers, but this could be improved upon by providing an initial condition where the breakers start open and are closed consecutively over the course of 18 seconds. Additionally, this update solved another problem, by chance, in which the LabVIEW code would occasionally start and run but not record any measurements. Perhaps the delayed startup ensured the network connection had been established and measurements could be recorded. The next test was ensuring that the LabVIEW code was at least recording the most balanced state, since it failed to select the most balanced state in our initial test for the CDR. By using the Excel spreadsheets designed for the initial CDR testing, it was possible to record values and compare them easily with their respective LabVIEW values in order to validate the lowest variance state or the most balanced state. By comparing the lowest value for variance calculated in Excel with the value of variance displayed in the minimum value box of the LabVIEW graphical user interface, it can be concluded that the array is correctly holding on to the state with the least variance. The next step will be to ensure that this array is connected with the solution state, and that this solution state is selected at the conclusion of the program. This concludes my test plan.